let's start this section with a quick review of the definite integral. Just remind ourselves what the basis of the definite integral was, because we're about to need it when we start talking about or getting into the idea of double integrals over rectangles. First of all, recall from Calc 1 that we can estimate the area under the curve from A to B by dividing the curve into intervals and then finding the sum of f of xi times delta x. Now, if we draw a quick picture of this, essentially we're talking about some curve over this region from A to B. And what we're going to do is divide this thing up into these subintervals. So like, I'm going to go do a couple of intervals here. 3 is good enough to demonstrate what's going on. And what I'm going to do is I'll say, hey, look, I can pick a value anywhere in this interval that I want. So let's say I pick right here. This is where I'm going to pick x1. And because we're not using an endpoint, I'm going to use an asterisk to denote that this x is anywhere in here that I want. Likewise over here, I'm going to pick x2. And in here, somewhere is good enough. I'm going to pick x3. And so if I come up to the curve, my box is going to look basically like that. This one is going to look essentially like this. Okay, granted, I did not scale these very well, but you get the idea. And there's my third box. So that's what this asterisk simply means, that I can pick any x in the interval that I want. Then once I have this sum as an approximation, I know that I can take the limit as n goes to infinity of the sum I equals 1 to n of f of xi, and again I'll denote that with an asterisk, delta x, and that is actually equal to the integral from a to b of f of x dx. Of course, we have issues of continuity and so forth, but in general, that we can make this claim. And also recall that if f of x is greater than or equal to 0 on this interval a to b, then we can interpret the results of this integral from a to b of f of x dx as area under the curve. So just as a very quick reminder of how we did this, or what we did way back in Calc 1 when we first started introducing the idea of an integral, this we used like left endpoint, right endpoint, midpoint, and then eventually said, hey, I can pick any point in here. And this is the sort of thing that we did. So what we really need now is to come up with a similar concept or a similar process that we can apply to the idea of functions of either 2 or 3 variables.